Hey everyone, I got a request for the 10.2 homework for hypothesis testing. If you haven't checked out the video and the announcements about how things are connected, I think I titled it something about how does everything connect or something like that. Check that out as well, maybe before this video. I'm just going to go through a typical homework problem from say 10.2. So a lot of the questions are going to ask you about if the situation satisfies the conditions for the central limit theorem to kind of work, thinking back to chapter 8. So every one of them is going to ask you about this NP 1 minus P requirement. So in order to do that, you're going to get your calculator, which I don't have out yet. Here it goes. So for this one, we need the P naught is going to be the value that is in your null. So what's the value that's assumed to be true? So in our case, it's the 2.4%. So that's 0.024. That's the P naught. So I'm kind of doing that. Multiplied by your sample size, so 873. Multiplied by 1 minus P naught. So if 2.4% is P naught, then 1 minus P naught is what, 97.6, so 0.976. And we need this number here to be at least 10. It is, it's 20. So let's see, round to one decimal place. So 20.4 should work. That value is going to be greater than 10. That's what we need for it to be. The sample size needs to be less than 5% of the population size, and the sample is given, I imagine. Didn't read the problem. I guess I should have done that. I guess we're going to have to say reasonably assumed. I don't see that it says that it's randomly selected, but we're going to have to assume that it is in order for us to kind of proceed and meet the conditions. Sorry for that coming in. And then therefore, the requirements for the hypothesis test are satisfied. All of those are going to have to be satisfied, or you're not going to be able to do the problem. So it's really going to be about what is the n times P naught times 1 minus P naught, what is that value? But everything else is going to have to be satisfied or you can't proceed. So you're always going to have a value here that's bigger than 10. The sample size is going to have to be less than 5% of the population size. It's either going to say it's random or you're going to have to assume that it is, and therefore you're going to have to say that it's satisfied. For the null and the alternative, the null is always going to have equal. I don't even have to look. For here, we're dealing with a population proportion, so that's P. When you get to 10.3, you're going to be looking at mu as a parameter, but for us, it's P in this one, and we're assuming that it's 0.24, right? So don't put it as percent. Everything else here is going to be the same, except we're going to have an inequality here. That's going to come from the problem. So look at this last sentence. Is there sufficient evidence to conclude that more than, so your alternative is going to be greater than there. And then, what did I mess up? My decimal's wrong. It's 0.024, sorry. 2.4% is not 0.24, that's 24%. Let's try that again. There we go. And now it's asking for the test statistic. Now, you can compute this by doing a z-score. The divisor of the z-score, the standard deviation, is going to be the standard deviation from chapter 8, which is the square root of p times 1 minus p over n. You are more than welcome to do that. I am not, because I'm lazy. So I'm going to go to statcrunch.com. I'm already logged in, so I'm going to be good. I'm just going to go to StatCrunch. And then I'm going to go to stat. We're working with proportions. We have one sample, and I have summary. I don't have a list of people that do something with drugs. What was it? Complain of flu-like symptoms. So I'm using the summary. I'll move this over here. So it says in the problem, we need to figure out how many out of our sample complained of flu-like symptoms. So it looks like 23 out of 873. So I got 23 out of 873. Our null, we already said, is 0.024. And we said our alternative is greater than. So notice it's in the same spot where the confidence interval is computed, except we're doing, obviously, hypothesis testing. And notice we're doing a p, right, because it's a proportion. And then we're going to get all the information we need from here. Let's see if I can fit this on the screen. Maybe not. Sorry. So here we go. We can pull the test statistic and the p-value straight off of this. So the test statistic is the z-stat, so that's 0.452, I believe, or 0.45. It only wants 2 decimal places. And then it's going to ask for the p-value. The p-value here is it wants 3, so 0.325. And then it's going to ask us to make a decision. So in terms of making the decision, you're comparing the p-value to your alpha value. Your alpha value is 0.05. 0.325 is bigger than 0.05, so that's obviously going to be C or D. Since the p-value is bigger than alpha, we're going to not reject the null. And then therefore there's not sufficient evidence to conclude the alternative. And you're going to notice that the interpretations are always in reference to the alternative hypothesis. So that should do it. All of them are going to be pretty much similar to that. When you get to 10.3, it is going to change in terms of the variable that you're working with. You're going to work with a quantitative variable, asking people if they have flu-like symptoms as a qualitative variable, because they're going to respond with like a yes or a no as opposed to a number. In any case, I hope that this helps. If you have any questions, by all means, let me know.